Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today our lecture is about the soil mechanics, and in this lecture we are going to solve one numerical problem taken from the soil mechanics book. The problem states that find the total stress, effective stress in the pore water pressure. So this is the soil profile given to us, which consists of sand and the clay. The sand has a thickness of 4 meter, while the clay has two different layers. One layer is 3 meter and the other layer is also 3 meter thickness. So, and the corresponding unit weight of these layers are given. The gamma 1 represents the sand and the gamma 2 and gamma 3 represent the clay, while they have different unit weight. And also there is a pressure of 40 kilonewton per square meter acting at the top of the soil. So we have to find and draw the profile of total stress, the effective stress and the pore water pressure. So to start with the total stress, so first of all we have to find out these all stresses at the different points. For example, the 1 1. We have to find the stresses at this 1 1 point, at this layer, at 2 2, and this is the third point. So this is the at this layer, and this is the fourth point. So we have to find out the total stress, the effective stress and the pore water pressure at all these points. So at 1 1, so it means the top of the soil. So at the top of the soil, the total stress is equal to the total pressure acting on the soil, which is Q in this case, and it is equal to the 40 kilonewton per square meter. There is only the external pressure acting on the soil, so we can call it Q, and it is equal to 40, while there is no pore water pressure is equal to 0, because there is no pore water pressure because the water table is acting below the 1 1 point, so it is 0. And also the effective stress will be equal to the total stress minus pore water pressure. The total stress is 40 minus the pore water pressure is 0, so it comes out to be 40 kilonewton per square meter. Now to find out the stresses at 2 2. So at this point, so we still don't have a water table at the 2 2, and this water table is given to us at a distance of 4 meters from the top of the soil. So at this 2 2 we don't have any water table, so again the pore water pressure will be 0. So at 2 2 the total stress will be equal to 40 plus, because 40 is acting as external pressure and aiding with the gamma 1 multiplied with the H1, where this I call as H1, this I call as H2, this I call as H3. So we have three different thicknesses and we have three different gammas unit weight. So that's why we have to multiply each unit weight with its own height or the thickness of the layer. So 40 and gamma 1 multiplying with H1, we will get the total stress at this 2 2 point. Gamma 1 is 18, H1 is 4. So by adding this value, we get 112 kilonewton per square meter. Now the pore water pressure is 0 because the water table is acting below the 2 2, and the effective stress will be equal to the total stress minus pore water pressure. So it will again come out to be the same as the total stress. So effective stress is again same as the total stress. Now to calculate the stress at point 33. So at point 33 we already calculated the stress at point 2 2. So the total stress at point 33 will be equal to the stress at point 2 2 and adding with the stress at point 33. So at point 2 2 we know that the total stress is 112, adding with the remaining stress, which is gamma 2 multiplied with the H2. So 112 multiplied adding with the gamma 2 is 19, multiplying with the H2, which is 3. So we got the value of 169 kilonewton per square meter. Similarly, the pore water pressure. How to calculate the pore water pressure here? In this case, it will be the gamma water multiplying with the H2. So this is the height H2 now for the gamma W, because this is, we want to calculate the pore water pressure at 0.33, so we have to take the height above the 0.33. So the height from the 0.22 to 0.33 is 3 meter, so we have to take H2. So gamma W is, we know that it is 9.81 multiplying with the 3, so we got a value of 29.4 kilonewton per square meter. Now, how to find the effective stress? It is equal to the total stress minus the pore water pressure. So total stress is 169 minus 29.4, we get 139.6 kilonewton per square meter. Now to calculate the stresses at 0.44. So similarly, we have to add, we know that this stress is at 0.33, so we have to add the stresses of this layer, so we will get the total stresses at 0.44. So total stresses will be equal to the stresses at 0.33, which was 169, and adding with the gamma 3 with the H3, because gamma 3 and H3, this stress was unknown to us, so we found out here gamma 3 and H3, so it comes out to be 169, and adding with the gamma 3 is 20, multiplying with H3 is also 3, so it comes out to be 229 kilonewton per square meter. So this is the total stress acting at this 44 point. Similarly, the pore water pressure is equal to the water acting at this point, the pore water pressure acting at 44. So it will be the distance from this point, because the water table is from the 22 up to the 44. So this, the whole distance is 3 and 3, 6 meter. So gamma W multiplying with the 6, so gamma W is 9.81 multiplied with the 6, we get 58.9 kilonewton per square meter. Now the effective stress will be equal to the total stress minus pore water pressure. Total stress is 229 and pore water pressure is minus 58.9, so we get the effective stress is 170.1 kilonewton per square meter. Now we have all the stresses at different points. We have to draw the stress profile now. So starting with this point, this is my reference line. This is for the total stress, and then I will draw the pore water pressure, and then I will draw the effective stress profile. So the total stress at this point, which is 1, we know that it is 40, because 40 is there, 40 load pressure is acting at 0.11. So it is 40, and then at 0.22, and then 0.33 and 44. So at 0.22, the total stress was here 112. So it is 112. And there 0.33, it was 169. So it is 169. It is increasing with the depth of the soil. And then in 0.44, it was 229. So this is the total stress acting at the 0.44, which is 229. So we can see that the stress is increasing with the depth. Also, the pore water pressure, if I draw this as a reference line, so there is no pore water pressure at this point, 0. Again at 0.22, 3, 3, and 4, 4. So at 0.22, it is also equal to 0. You see here is there is no water table above the 22. So at 0.33, we have pore water pressure of 29.4. So we can draw a line here to, because it is at 33, so it is at 0.33, it will be equal to the 29.4, and then at 0.44 we have pore water pressure of 58.9 kilonewton per square meter. So this is the pore water pressure. It's also increasing with the thickness of the soil. Now to draw the effective stress profile is the reference line. At the 0 point we know that the effective stress is equal to the total stress 40, and then again at 0.22 it's again equal to the total stress, which is 112. At 0.33 it comes up to be 139.6. So at 0.33 139.6, and at 0.44 it comes out to be 170.1. So 170.1. So this is the effective stress profile. So after finding out all these values, we can easily draw the stress profile just by drawing the reference line and marking the main layer, the height of the main layers, and just drawing the curves according to the magnitude of these values. Like 40 is smaller than the 112, so it should stop earlier than the 112 value. Similarly, it's increasing, so our curve should be increasing. So this is the way how to calculate the total stress, effective stress, and pore water pressure, and to draw their profiles. Hope you guys understand, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.